Now that you know what you will be accessed on AO1, AO2, and AO3, it's time to talk about something that decides how you score those marks, the command words. These little words in the question, like define, explain, or calculate, may seem harmless, but they are actually the instructions from the examiner. Misunderstand them, and even the right answer can lose marks. In this video, I will break down the most common command words, show you exactly what they mean, and guide you on how to answer them like a top student. Let's make sure every word in your answer counts. These little words like describe, explain, and sketch might seem simple, but they carry a huge weight. So let's decode the language of physics together, starting with the word define. It is as simple as it sounds. The examiner wants a precise meaning, no extra fluff. For example, define pressure. The correct answer would be pressure is the force per unit area. If someone writes too vague, like it's like how hard something pushes, it would be considered wrong. A tip for define is that to keep it textbook level clear, just the definition. The second word is state, give, name, or identify. These all ask you to recall a fact, no need to explain or describe. For example, state the unit of force. You would write Newton, or N would be considered right because N is the unit for Newton. Another example is identify the component that controls current in a circuit. Your answer would be variable resistor. See, these are just one or two words. Keep it to the point. The third word is describe. Now we are talking what happens, not why. Describe the features, steps, or appearance. For example, describe the motion of an object in free fall. The answer could include it accelerates downward due to gravity. Don't explain why, just state what's happening. The next word is explain. Here's a big one. Now the examiner wants the why or the how. Link the cause and the effect. For example, explain why metal conducts electricity. Your answer could include because it has free electrons that move when a voltage is applied. Tip for explain is that use the word because to guide your answer naturally. Calculate. Use number, use formulas, and always show you working. For example, calculate the force when mass is 5 kg and acceleration is 2 meters per second. The answer would include the steps that F is equals to ma, 5 into 2 is going to give 10 Newton. Use correct formula, substitute value, and place a unit at the end. The next word is determine. This is like calculate, but it might also mean using a graph or doing measurements. For example, determine the resistance from the graph. Find the value from the axis, apply R is equals to B divided by I. Be precise, especially with scale readings. The next word is compare. Here you must mention similarities or differences. For example, compare sound wave and light wave. Your answer could include both transfers energy. Sound is longitudinal, light is transverse. Sound needs a medium for propagation, and light does not require any medium. Use structure like both, but it is a great formula for answering a compare question. The next is comment. This asks for your opinion based on an evidence. Don't guess, look at the data. For example, comment on the pattern in this graph. The graph shows a linear increase, suggesting a constant rate change. A tip here would be always link your comment back to what's given. The next word is deduce. This means figure it out using given information, even if it's not directly stated. For example, deduce the reason why the object stops moving. A general answer would be because the forces acting on it are balanced. So there's no net acceleration. Examiner love these thinking logically questions. The next word is justify. Give a reason with evidence or science. For example, justify your choice of fuse in a 3 ampere appliance. You would say that because the current is below 3 ampere, a 5 ampere fuse allows too much current before breaking. A 3 ampere fuse is safer. This is not just a choice, it's a defended argument. The next word is predict. You are being asked to apply what you know to something new. For example, predict what happens if the temperature increases. The pressure increases because the particle speed increases, causing more frequent collisions. This could be considered a good answer. Use prior knowledge to extend the idea. The next word is suggest. This is open ended. Apply your understanding to give a reasonable idea. For example, suggest one way to reduce heat loss in the experiment. You could say that use insulation around the container. The examiner isn't looking for a perfect answer, just a scientific one. The last word would be sketch. This means a simple freehand drawing using a graph or a diagram. For example, sketch a velocity time graph for constant acceleration. The right answer would be that the graph would start from the origin, a straight line upward. The axis should be labeled. Your sketch must match the physics, not artistic, but accurate. So the final tip here is you need to underline the command word when you read a question. Match your answer style to it. Definitions for define, explanation for explain, logic for deduce. Think for command words as clue. They tell you what the examiner want. So don't ignore them. So the next time you will be sitting in the exam, don't just rush the answer. Pause, look at the command word and let it guide your response. It's like the GPS for your answer. Follow it and you will never get lost. These were the bases that I considered important that usually other guiders ignore. Stick to it and you will definitely find your progress. And that wraps up today's video. We have covered the structure of O-level physics exam, explored the key topics, cracked the assessment objective, and decoded those tricky command words. Basically, we have built a solid launchpad for the entire physics journey. But we are just getting started. In the next episode, we will be diving into the most fascinating and the powerful area of physics, nuclear physics. We will explore atom, radiation, half-life, and the real world application like nuclear energy and medicine. Trust me, it's mind-blowing stuff and super important for your exam. So if you found this video helpful, make sure to like, subscribe, and hit that notification bell so you don't miss what's coming up next. Drop your question in the comment. I would love to hear from you. Until next time, stay curious, stay sharp, and keep learning physics the smart way. See you in the next video.